Okay, so we have question 7c. Acceleration depends on which two factors? Again, so I go to, which is Newton's second law, F equal A m. Okay, so acceleration depends on force, and net force and depends on the mass. So there's no position. Yes, here it is. B. Net force and the mass. You have mass and velocity. I don't have mass and velocity here. I don't have. So you just choose this one according to Newton's second law. Force depends. Sorry, the acceleration depends on two factors, which are force and mass. I go here. A student's stand, which is question 8a, on a bathroom scales as shows below here. So if I look at here, this is the mass. Okay, the reading on the scale is 50 kilograms. From the unit, I know it's the mass. Which of the following correctly states the mass and the weight of a student? Here it says which of the following, but it seems there are no options. Okay, but it seems the only thing that you need to know is the mass is the amount of matter, which is down. Yes, I got it. Which is question 8b, based on those factors. Okay, mass is the amount of matter in an object. And the unit is kilogram, while the weight is the pull of a gravity. Pull of gravity. I'll explain it here. So if I have people standing on Earth, okay, and one, let's assume on the moon. Here's the moon, okay? Let's say this is moon. The same person, assume that the same person stands on the moon, okay? The mass is the same. Go back to the mass, which is 50 kilogram. The mass here equal 50 kilogram. The mass here stays the same because the same person, okay? Equal 50 kilograms. So what's the difference here? The weight will be different. The weight here will be different than the weight here. Why? Because the pull of Earth is different than the pull of Moon. That's why the weight differs when people move from one planet to another. Okay, let's go to this question. Mass and weight, again, are different. Mass depends on amount of matter, and weight depends on the gravitational force based on which planet you are. Pull of gravity. Gravitational force means pull of gravity. So I don't have a place, cut it out. Force placement, cut it out. I have only two options left, A and B. Fine. Mass, the first blank and the second blank, you need to give them the same order. Blank A, blank B. Sorry, blank 1, blank 2, for example. So gravitational force and the amount of matter. If I say mass depends on A, gravitational force, this is wrong. Because mass depends on matter, amount of matter. Weight depends on the gravitational force, so the answer is D. Mass varies depending on where the object is located. Where the object is located? No. Because if you are in the Earth, your mass is the same as if you are in Moon, if you go to the Jupiter, if you inside the Earth, if you are in UAE to London to USA, your mass stays the same. Your mass does not change, so this is false. People don't lose their mass or get thinner when you move from one place to another. Your mass stays the same. So if your mass is 60 kilogram, it stays the same if you move everywhere in the Earth. If you go to another planets, your mass stays the same. It does not change the amount of matter in your body. Two objects, A and B, have the same mass as shown below. Both have the same mass, and you can tell from the size. If you look at them, the same size. What would happen to the force of A and B if the mass of A increased? What would happen to the force on A and B if the mass of A decreased? When you get a question like this, sorry, I just move. Okay, when you get a question like this, okay, you need to think about, which is we have gravity between those two forces. So the gravitational force between those objects depends on two factors. You need to remember the concept map. Depends on the mass, depends on distance. Between two objects, we have gravity. If the mass increases, the gravitational force increases. If the distance increases, the gravitational force decreases. So a proportional relationship, this is our inverse relationship, opposite. Okay, so if I increase the mass, the gravitational force are happy. If I increase the distance, the gravitational force will be sad. Okay, so let's go back to the question. So what I'm having here, what would happen to force A and B if the mass of B decreased? Any one of them. If any of them decreased, the mass of them decreased, the gravitational force decreased. So even if the mass decreases, the gravitational force decreases, same. So the answer is the force would decrease. This is answer A. Exactly. Right. The force would decrease. Okay. The question, I think, I solved the question here, 9B. Okay, it's similar to even 9A. Okay, here is the same answer. I'll go back to this question. What happened to the force of A? If the mass increases, the force would increase. Okay, any one of them. If the mass of A increases, the gravitational force between them will increase. If the mass B increase, the gravitational force between them would increase. And if the decrease is the same. So let's say this is a question. Okay, I will erase this. Okay, so this question, let's go for this here. Okay, so again, what would happen to the force on A and B if the mass A is increased? So the correct answer, the force would increase. Okay, and here, what would happen to the force on A if A decreased? The force would decrease, because there's a proportional relationship between the gravitational force between two objects and their masses. And all the time, remember the concept map about the gravitational force affected by two options, which is two factors, sorry, mass and distance. If the mass increases, the gravitational force increases. If the mass decreases, the gravitational force decreases, proportional. Well, the opposite with distance. If the distance increases, the gravitational force decreases, and the opposite is true. Okay? Now, okay, the same question is 9B. If the mass of one or two spheres increase, what would happen to the effect of the gravity between two spheres? Go back here. If the mass increases, the gravitational force between them and the gravity would increase. So the gravity increases. It's not this, it's not fluctuate. Fluctuate means increase and decrease, increase and decrease, and the gravity is not affected, which is not true.